Hello students, in the previous video we saw 3D transformations like scaling and translation. In this video we are going to see 3D transformation which is called as rotation in 3D. Okay, just like rotation in 3D, just like rotation in 2D, rotation in 3D also follows the clockwise or anti-clockwise matrices. So we are going to use the same matrices which we have used for rotation in 2D. Okay, but you have to remember certain things when it comes to rotation in the three-dimensional space. Okay, now certain things that you have to remember, out of which if you rotate in 3D around x-axis, that means you have to perform 2D rotation in YZ plane. Okay, if you rotate in 3D around y-axis, you have to perform 2D rotation in ZX plane. If you rotate in 3D around Z axis, you have to perform 2D rotation in XY plane. Okay, so with this it becomes clear that 3D rotation is nothing but 2D rotation, only the planes differ as and when the axis differs. Okay, so if it's the X axis, it's the YZ plane. If it's the y-axis, then it's the zx plane. If it's the z-axis, then it's the xy plane. Okay, so you have an xy out of xyz, whichever axis it is, you just eliminate that particular axis, and then the remaining two alphabets will be the plane in which you are going to perform that particular rotation. Okay, now this can be understood with the help of a diagram. I have a diagram over here. Okay, the reference of the diagram is taken from the textbook Computer Graphics by Donald Hearn, also pronounced as Donald Earn, and M. Pauline Baker. It's a very good textbook if you have to learn computer graphics in detail. Okay, so this diagram is taken from this particular textbook. Let's look at this diagram. This is the direction of the onlooker. Okay, so this person is looking towards the xy axis. Okay, this person is looking towards the xy axis, and this is how the rotation is being performed. Okay, now looking towards the origin from a positive coordinate position on each axis. Now if the rotation is to be performed along the z axis, then the onlooker is going to be placed here, and the onlooker is going to be looking at the origin, and the rotation is going to put this. Now this particular direction that I have made is for anti-clockwise direction rotation. Okay, now this can also be imagined as you or the onlooker holding the z-axis in his hand and performing an clockwise or anti-clockwise rotation. Okay, that is the imagination that will help you all to understand what kind of rotation, like how the object is going to look in the 3D space when it is rotated about the z-axis. Okay, now one more example that I can give you is from the same textbook that I just mentioned. Okay, so I am performing rotation about the z-axis over here. Okay, so just imagine, and here also the anti-clockwise movement is being done. So just imagine that you are holding the z-axis in your hand and you are moving the object in the anti-clockwise direction. So the rotation is going to happen like, once the rotation happens, the object is going to look something like this. So this is what happens when the rotation of an object is about the z axis. Okay, now next we are looking at the rotation of the object about the x axis. The rotation of the object about the x axis, the onlooker is going to be over here, right here. This, he is going to look at the origin from this direction, and again the anti-clockwise rotation. Okay, now so like I said, for the z axis, you imagine that the onlooker is holding the x axis and rotating it in the anti-clockwise direction. Okay, so this is how your object will look when it is rotated in the when it is rotated in the anti-clockwise direction from the x axis. So this is how the object is going to look. This is the original position of the object, this is the rotated position of the object. So this is how the object is going to look when it is rotated about the x axis. Okay, now moving on to rotation about y axis. Now this is rotation about y axis. This is the onlooker right here, he is looking into this direction towards the origin, and I am performing the rotation about the y axis. Okay, now in order to perform the rotation about the y axis, like I said, you have to look from the direction of the y axis. Okay, and this is how the object will look once it is rotated in the anti-clockwise direction towards about the y axis. That means it will be rotated in the xz plane. If it is rotating from the y axis, it will be rotated from the xz plane. Okay, so it will perform 2D rotation in the xz plane since it is being rotated from the y axis. Okay, so this is how your 2D your 3D rotation works. Now let's see how you mathematically represent the 3D rotation in terms of matrix. So like I mentioned, you are using 2D rotation. Okay, you are using 2D rotation. Let's see this once again. If you're rotating a 3D rotating 3D around x axis, that means you're doing 2D rotation in yz plane. If you're rotating in 3D around z axis, that means you're doing 2D rotation in xy plane. Okay, so let's look at the matrix that we are designing for z axis. Okay, so rotation in 3D around the z axis, where x, y and z, okay, your points p, x, y and z are my original points, and p dash of x dash, y dash and z dash are my modified points. Okay, modified points post rotation around the z axis. So what do I have over here? I have x dash is equal to x cos theta minus y sin theta, y dash is equal to x sin theta plus y cos theta, and z dash is equal to z. Please note that if you are rotating around rotating in 3D around the z axis, the original value of the z axis and the modified value of the z axis will remain the same. Similarly, if you are rotating around y axis, the original value of the y axis and the modified value of the y axis is going to remain the same. The same applies for x axis as well. Okay, now we are going to write the homogeneous matrix for your rotation about the z axis. Okay, so x dash, y dash, z dash 1, this is my modified point, this is my modified p. Okay, now what is my matrix over here? Cos theta minus sin theta cos theta, 0 0 0 0 0 0 0 0 0. So this is the value for my x dash. Okay, etc. I hope you can see this. This is the value for my x dash in this direction. This is the value for my y dash in this direction. Okay, so this is x dash, cos theta minus sin theta. I am writing cos theta minus sin theta here. Y dash is sin theta. I am not writing x and y because the positions are understood. Okay, so y dash is sin theta cos theta, sin theta cos theta. This, my dear students, is rotation, 2D rotation in clockwise direction. This is the matrix for 2D rotation in clockwise direction. So like I said, we are going to use the matrix of 2D rotation in order to make your matrix for 3D rotation. Okay, now that we are done with the rotation about z axis, we are going to see rotation about x axis. Okay, so it's very similar to rotation about z axis, only the matrix changes. So like I said, for z axis, the value of original z and the modified z remain the same. Just in the same way, for x axis, the value of original x and the value of modified x is going to remain the same. Okay, my y dash is going to be the same matrix, I'm going to use for the same matrix for 2D rotation about in the clockwise direction. So that is y dash is equal to, now since x is equal to x dash, my and this the rotation is about the x axis, so this is going to be y cos theta minus z sin theta, and z dash is going to be y sin theta plus z cos theta. So if you can observe, this sin cos theta minus sin theta plus cos theta remains the same in both the mathematical representations, this as well as this. Only the thing is, here there is x, y, okay, because we are performing rotation about the z axis, and since here we are performing rotation about the x axis, it is y, z. in the mathematical representation. Similarly, we are going to write the matrix now. Okay, so let's do that. X dash, y dash, z dash 1, x, y, z 1. Okay, so like I said, your matrix is represented in the form of x, y, z and the homogeneous coordinates. So 1, 0, 0. Because we are performing a rotation about the x axis will remain as it is. Okay, the y axis will be cos theta minus sin theta, cos theta. I am doing nothing but simply picking these values and placing it at the position of y and z. Okay, now let me just tell you, this is x, y, z, this is x, y, z. Okay, now since I am performing rotation about the x axis, my x over here in this line will remain empty and in this line it will remain empty. It's going to be 1 because x dash is equal to x, so it's going to be 1. Okay, y on the other hand will be cos theta, this value over here, sin theta, this value minus sin theta, this value over here, and z on the other hand is going to be sin theta, this value over here, and cos theta, this value over here. Okay, rest everything is going to be as it is as you write for the homogeneous coordinates. So this is going to be 0, 0, 0. Okay, so this is rotation about x axis. Now let's quickly write the mathematical representation for rotation about y axis. (3D) rotation about y axis. Right. So this is my x dash, this is my y dash, and this is my z dash. Since we are performing 3D rotation about y axis, y dash is going to be equal to y. Okay, and x dash is going to be in terms of z and x now, right? So this is z cos theta minus x sin theta, and this is z sin theta plus x cos theta. Okay, the matrix is going to be x dash, y dash, z dash 1 is equal to x, y, z 1. Okay, and since this is y, rotation about y axis, that means my y will remain as it is and my x position is going to be changing. Cos theta 0, sin theta 0, 0, 1, 0, 0, minus sin theta 0, cos theta 0, 0, 0, 0, 1. Okay, so this is my matrix for rotation, 3D rotation about y axis, which is going to happen in which plane? It is going to happen in the xz plane because the rotation is about the y axis. So this was about 3D rotation, and 3D rotation is a bit more complicated than 2D rotation because you have to consider in which axis or about which axis the rotation is happening. Okay, so this was all about basic 3D transformations. Thank you.